Jerel. I'm a backend engineer at Toyota Connected, and we're building the mobility services platform. So at Toyota Connected, we're tasked with building products for car sharing and fleet management. And that means we need to solve problems that look like this. And if you deal with tracking locations of objects, you've maybe solved this problem, or you'll need to eventually. And that is, how can you be notified when an object you care about enters or exits an area of interest? So the areas of interest are polygons called geofences or zones. And this is simple when there's just a few objects and a few objects and geofences, but what if there's any number of each? Toyota sells about 10 million cars per year, and we're building global software, so we need to plan for significant load. So the simple way is to query a database every time an object moves, but that would generate tremendous load. So instead what we have here is a streaming database that holds a state for each live object, and as that object moves, we run calculations for each time it updates. And then this database emits enter and leave events as it interacts with the geofences. When we run this in a cluster, each node can hold a copy of the geofences so it can do these calculations locally. And these geofences can be shared with Amnesia. Since each object has its own process, how do we set initial state when a vehicle's process starts? Postgres or other long-term storage. So when an object's process starts, it fetches the last known state for that vehicle or object, whatever you're tracking. And then when that object enters or leaves a geofence, the database can emit an enter or exit event and send it somewhere with PubSub. Or it can periodically save the object state back to long-term storage. So here we have a process that died, and it goes away. And so all the state, anything that you knew about that vehicle is gone. So when it respawns, we pull the last known state from long-term storage, and now we know how to run calculations on it again. We can carry on with live data processing. So what about handling the mathematical load in Elixir? Here's every city block in the borough of Brooklyn, New York, and that's a little over 5,000 geofences. And these red dots represent 10,000 vehicles driving through the city. So I'll show a demo here, and this is what the setup looks like. The top graph is Observer, and that's CPU load. And this is running on a 4-core DigitalOcean droplet. And for this example, we have 10,000 vehicles, and each one is updating their location every second. And as they drive through the polygons, the database will emit the enter and exit events. So the first thing that will happen when a node starts is we load all these geofences in using a library named envelope. And that allows very efficient spatial lookups. So I'll start this, if I can find my mouse. There we go. So now it's loading the geofences in. And that causes a little CPU spike when the node starts. And now we're pushing vehicle location updates through, and we're pushing about 10,000 per second. And you can see that processing, it's comparing against 5,000 geofences in about 500 microseconds. And we're stable at about 10,000 updates per second. And that's one node. So then this is using Swarm, and so these processes for the vehicles can be running on any node in the cluster. So when we do a lookup, that can be run on the local node or a different node. So we care a lot about open source at Toyota Connected, and most of the code behind this is open. We're using Envelope and Topo for sure. And these are all on Hex, so feel free to use them, and you can contribute back to them if you like. We're also hiring, so if this sounds exciting, feel free to talk with one of us, and we have a table outside too. That's it, thanks.